Hello everyone. In this video I am going to go over the Math-108 homework on standard deviation. So for the first part here we're going to actually calculate a standard deviation, not exactly by hand, but like with a hand calculator. So I have the steps all laid out for you here. And oh, I guess I forgot to say which version of standard deviation we're doing here, or even that we're doing it at all. Reading my own instructions, I forgot to say I think we should put, follow the steps below to calculate the standard deviation population version. Sorry about that. It's a danger whenever you write your own questions. All right, so these are the data values that we're going to find the standard deviation of: 2, 3, 5, and 8, and we're saying that these are some quiz scores. So first we have to find the mean of the data, so we're just going to add these up and divide by how many there were. So 2 plus 3 plus 5 plus 8. You can use a calculator, or maybe you can do this in your head. This is a total of 18. Divide by 4, so I think, let's see, I have a calculator here. So this should be 4.5. Okay. All right, so now we're going to fill in this little table here. So we have the data values in the first column, 2, 3, 5, 8, and then the deviation in the second column. It doesn't matter if you mix up which one you're subtracting. You can do data minus mean, or you can do mean minus data. The reason it doesn't matter is because we're going to square it in this column, and everything becomes positive when it's squared. So if you reverse these two, then it just changes the sign from positive to negative, but it's going to go away when we go over here anyway. Okay, so I'm just going to do them in the order that I've written here, which is data minus mean. So 2 minus 4.5, I'm going to put that in a calculator, and I'm going to get negative 2.5. Or you can do that in your head, maybe. 3 minus 4.5, that's negative 1.5. 5 minus 4.5, that's 0.5. And then 8 minus 4.5 is 3.5. Okay? And then over here, I'm going to take all of these numbers that I just got, and I'm going to square them. And again, once you square it, the sign goes away. So when you're typing this into the calculator, you don't have to put in the negative. You can just square positive 2.5. Okay? So this is 2.5 squared, 6.25. 1.5 squared is, I'm using an actual hand calculator, not my computer one. 0.5 squared, that should be 0.25, I know that one. And then 3.5 squared is 12.25. Okay, so now we're going to add these up. So 6.25 plus 2.25 plus 0.25 plus 12.25. And we're getting 21. So nice round number there. I guess because they all ended with 0.25. All right, and then the step 3 here is to actually take the average of these squared deviations, so we get the total of them and then divide that by 4. So 21 divided by 4, this is 5.25. And then lastly is just take the square root of that number that you just got, the 5.25. So that sort of undoes the squaring that you did over here, in a sense. So 5.25 square root. Usually I would round to 3 decimal places. If nobody tells me what else to do, I'll do like 3 significant figures, so 2.29. All right, so this is, just make it absolutely clear here, I'm taking the square root of 5.25, and that is approximately 2.29. Okay, and then the meaning of this number is that most of the data, we're guaranteed 3/4 of the data values will lie within 1 standard deviation of the mean. So if we go to the mean of 4.5, we go up by 2.29, we go down by 2.29, 3/4 of all the data should be in that range, which I believe it might even be, yeah, I think all of them except for 2 in this case. So if we do 4.5 minus 2.29, that's not quite 2, it's a little bit above 2. And then 4.5 plus, well, actually, are we getting the right criteria? Oh, no, I'm sorry, it's within 2 standard deviations of the mean is 3/4 of the data. Sorry, I remembered the guarantee wrong. So within 2 standard deviations, yeah, all of it should be within 2. All right, anyway, we're going to talk more about that concept on this next part here. So being within a certain number of standard deviations of the mean. So there are 76 private four-year colleges and universities in Pennsylvania. The number of students at each during fall 2024 is listed below. This data is from Wikipedia, by the way. The mean number of students is approximately mu equals 3,516. Here I'm just reminding you that mu is the letter that stands for the population mean. I can call this the population mean because this is all of the private four-year colleges and universities. It's not just a sample. And then the standard deviation is approximately sigma equals 4415. So sigma is bigger than the mean, which sometimes happens with like very unbalanced data. You can see this data is like quite unbalanced because most of the numbers are kind of small, like less than 10,000, but then you have a few that are really large, like these last three. Okay, anyway, how many data are within one standard deviation of the mean? So what I'm going to do is I'm going to find out what are the boundaries on the region of numbers that would be within one standard deviation of the mean. So I'm going to go to the mean, mu, then I'm going to go up by one standard deviation, and then I'm going to go to the mean, and I'm going to go down by one standard deviation. You picture this like on a yardstick or like on a number line, like the real number line. I'm finding two numbers, and then I'm going to just count how many of these data values up here are between those two numbers. Okay? So mu plus sigma is going to be 3516 plus 4415, and I'm going to get out a calculator and actually add this up. So 3516 plus 4415, that is 7931. And then I'm going to do my lower number, mu minus sigma. You can do the lower one first. I don't know why I always do the larger one first. I guess I just like addition better. Actually, I don't really care what this is. It's some negative number. I guess I'll calculate it. But as soon as I see that it's negative, I know that it's lower than the lowest data value that I have because all of mine are positive. But yeah, let me just go ahead and calculate it anyway so you guys can see the like cookie cutter way to do this correctly. Okay, so now what I'm going to do is count how many data are between negative 899 and 7931. And usually there aren't any that are like right on those numbers. But if there were, we're talking about being within one standard deviation. So the word within is like a little bit ambiguous. If you're exactly one standard deviation away, are you within one standard deviation? I would say you are, but it's a little bit ambiguous. Okay, but we almost never land right on those boundaries. So all of the data are larger than negative 899. And then where do they stop being larger at? Let's see. All of these ones are less than 7931. I think, oops, I lost the top part. It should be these ones that I've just selected. Those are the ones that are in the range of those two numbers that I just got. So how many is that? I think it's easier to count if we count the ones that are not in it. So the ones that are not in it are 1, 2, 3, 4, 5, 6, 7, 8. And then there were 76. So I think 68. Yeah, 68 of the data are between the numbers. Okay, so 68 of the data are within one standard deviation of the mean. That's what this means. Okay, let's go ahead and look at number 6 then. How many of the data are within two standard deviations of the mean? So we're going to do this exactly the same way, except instead of going to the mean and going up by one standard deviation, I'm going to go to the mean and I'm going to go up by 2 standard deviations. And then I'm going to go to the mean and I'm going to go down by 2 standard deviations. But other than that, this is like exactly the same thing. And I'm just counting how many data are between those. It's very easy. So it's so easy, I'm just going to paste these down here and then I'm just going to put a 2 in front of sigma. So 2, 2, this is going to be 2 times that, 2 times that. Okay, and then I'm just going to recalculate these numbers. This one is still going to be something negative, so as soon as you see it's negative, it doesn't really matter what it is, because all your data are positive, so they're definitely greater than that. But I'll just go ahead and calculate it, because I know that kind of like freaks you out sometimes when I start applying some like random mathematical logic, because you never know when is it okay to do that, when is it not okay to do that. I would say it's always okay to do that. Okay, so 35, 16 plus 2 times 44, 15, 12, 3, 46. Oops, that's not 12. There we go. Okay, so now how many of the colleges and universities are between those two numbers? So it's going to be all of them up until until here, I think. So all but 3. So all but 3 is going to be 73 of the data are within 2 standard deviations of the mean. By the way, standard deviation, a pretty standard abbreviation, is STDDEV, or sometimes people like this STDEV. Yeah. All right. And by the way, the guarantee that we get mathematically is that no matter how weird your data is, at least 3/4 of it will be within 2 standard deviations. I forgot what it was earlier in the video, but it's like you take this number here and you square it, and that's the denominator of the fraction that you get. And this is a lot more than 3/4, right? 73 out of 76 is much greater than 3/4. So we have seen that that guarantee was true for this particular data set. Okay, last question. How many of the data are more than 2 standard deviations above the mean? So above meaning meaning greater. So it's these last 3 that are further above the mean than 2 standard deviations. We don't yet have a formula. We haven't worked out the formula yet during class, but we will soon to figure out exactly how many standard deviations above the mean are these data values. But since they're not within 2 standard deviations, then they must either be more than 2 below or more than 2 above, and they are above because they're greater than the mean. Okay, so it's the three of them. 3, the greatest 3 of the data values. Okay, hope that makes sense to you guys. Microsoft Word fighting me as usual on tabs. And that is it for this video, so I will see you guys in class.